Hello everyone, today in this video we are going to solve some numerical by applying Coulomb's law. So after this video you should be able to apply Coulomb's law. We already know according to Coulomb's law the force between two charges is directly proportional to the product of their charges and inversely proportional to the square of their distance. And out here k is the constant and value of k is 9 into 10 to the power 10. And we can write k as like this. So the final formula for Coulomb's law will look like this. So we can either use this equation or this equation. So this is the first question. Suppose a sphere A and B have identical size and charge. A third sphere C of same size but uncharged is brought in contact with A and then with B. What is the new force between them? So out here it's saying there are two charges and they have equal charges and same size. So before bringing the third sphere, the force between them is F is equal to kq square by r. So by putting this value I can get this. Now if I bring the third sphere which has zero charge in contact with this, they distribute the average charge. That means the half of the total charge. So our total charge will be divided into half and half. So if I bring this in contact with this, then again the half of the total charge will be distributed. So this is the charges. So the charge is q plus q by 2 and half of this. So if you solve this you will get 3q by 4. So each of the sphere will become 3q by 4. So the new charges will be q by 2 and 3q by 4. So instead of this drawing you can write this equation. Now I am writing the same thing. The charge on sphere A will be q by 2 and charge on sphere B will be 3q by 4. So now new force will be F dash is equal to k qa qb by r square. So now I'll put the value of qa and qb. Now I'll solve this. So you'll get F dash is equal to k 3q square by 8 whole divided by r square. So now you can take this 8 down and now you can take this 3 and 8 in front. Now if you see this kq by r square, it was the initial force before bringing the charge C. So out here you can see. So instead of this you can write force, that is the old force between two spheres. Now you can see new force is 3/8 of the old force, or new force will be 0.37 times the old force. So the force got reduced. Next question. Two identical metal spheres having unequal opposite charges are placed at the distance of 0.9 meter apart. After bringing them in contact with each other, they again placed at the same distance apart. Now the force of repulsion between them is 0.025 Newton. Calculate the final charge on each of them. So they are saying two charges are having unequal charges. So let q1 q2 be the charges. Now after bringing them in contact, that means if we bring them in contact they will have the same charge. So I can write q to be the charge because they will have same charge. So new q1 and q2 will be q only. So now I can put the value of force, I can put the value of distance. So out here, so I forgot to write given, so you should write given out here, the things which are given. So now if I solve this, taking this 9 square up and this down, so you will get q is equal to 1.5 into 10 to the power minus 6 Coulomb. To make the video short, I have skipped some of the calculation. Suggest you not to skip those calculation. Now the next question. Sum of 2 point charges is 7 microcoulomb and they repel each other with a force of 1 Newton when kept 30 centimeter apart in free space. Calculate the value of each charge. So out here given is q1 plus q2 is given, that is 7 microcoulomb. So micro is 10 to the power minus 6 and distance is given 30 centimeter. Centi means minus 2, so because of this 0 I'll get minus 1. So 3 into 10 to the power minus 1 meter, and force is given 1 Newton. So we have to find q1 and q2. So using Coulomb's law, we can write this. So if I put the values, so force is 1 Newton and other values Q1 and Q2 is not given. So when you square this, 3 square is 9 and 10 to the power minus 1 square is 10 to the power minus 2. So I'll cross multiply to take Q1 Q2 this side. Next Q1 Q2 is 10 to the power minus 11. So we have got Q1 into Q2. So but we know a plus b whole square is a square plus b square plus 2ab. So if you add minus 2ab and plus 2ab, nothing will happen because this will make 0. So we'll get the same equation again. So now if you add 2ab it will become 4ab. So now this is a square plus b square minus 2ab. So this is a minus b whole square. So now if you take this a minus b whole square this side, you will get a minus b whole square is equal to a plus b whole square minus 4ab. Now I am writing the same formula for our problem. So a minus b whole square is equal to a plus b whole square minus 4ab. So you don't need to write all the steps, just write this formula in your answer. Next, now I'll put the values. So q1 plus q2 is 7 microcoulomb and q1 into q is 10 to the power minus 11. So I'm putting the values. When I solve this, I'll get 9 into 10 to the power minus 12, q1 minus q2 square. So if I find q1 and q2, it will be root over of this. So root over 9 is 3 and root over 10 to the power minus 12 is 10 to the power minus 6. And q1 plus q2 is 7 into 10 to the power minus 6, which is already given. Now I'll solve this equation. I'll add these two equations. So I'll get 2q1 is equal to 10 into 10 to the power minus 6. So your q1 will be 5 into 10 to the power minus 6. Now you can use this equation again, put the value of q1. So if you put the value of q1, your q2 will be 2 into 10 to the power minus 6 coulomb. Next question, two identical point charge of magnitude q are kept at a distance r from each other. A third point charge q is placed on the line joining above two charges such that all three charges are in equilibrium. What is the sign, magnitude and the position of third charge? So in this question, q and q are placed at a distance of r and the third charge q is placed in the line joining these two. So you have to find the position of this charge and the magnitude of this charge in terms of q. So let us assume that we are keeping this at the distance x from this charge point A. So I am giving point A and point B so that it will be easy for me to write the equations. So now for equilibrium, now these two charges will repel each other, so they will try to go away from each other. Now I have to put other charge q so that they will stay at their position. So first they are repelling each other, so I should put positive charge so that these two charges will get attracted towards this q, so this will be in equilibrium. So first they are repelling. Now if you put negative charge, this will try to attract this two and it will remain in equilibrium. So if you put the positive charge, it will not be in equilibrium because all three charges will repel each other and they will go away from each other. So now I am taking the same diagram. Now let's solve. So for equilibrium, q must be negative. Now I am keeping the charge small q at distance x from A. So now the force between these two charges is Fa. So because it's attractive force, so this will try to attract this. So I am denoting this by Fa, and Fa is given by K capital Q small q by distance square. Distance is x out here. So similarly, the force between this q and this q will be, so this distance will be now r minus x. So this will be k q by r minus x whole square. Now for equilibrium, these two forces must be equal. So I can write Fa is equal to Fv. Now if you put the values, you can cancel this k and k, and you are left with this. And if you solve this, now this square also get cancelled. So x is equal to r minus x, or 2x is equal to r, x is equal to r by 2. So this charge has to be kept in the center, that is r by 2. Now let's find the magnitude of this charge. So to find the magnitude, I'll consider the force on this charge due to this and this. So this charge will be repelled by this and this charge will be attracted by this. So for equilibrium, this repulsion and attraction should be equal. So I'll write F capital QQ, the force between this Q and this Q, and the force between this Q and this small q must be equal. So now if you use the Coulomb's law again, so this will be q square by 4 pi epsilon r square, and the force between these two will be k q by x square, and we already know x is r by 2. So if you put the values, you will get q to be capital Q by 4. So this is the final expression. So we have got the sign, that is negative, we have got the distance, that is x by 2, and we have got the charge, that is capital Q by 4. So next question, now 2 point charges plus 4e and plus e units are separated by a distance. Where should the third point charge be placed for it to be in equilibrium? What should be the nature of Q for the stable equilibrium? Now according to the question, the charges 4e and e are placed at a distance of a. So we are keeping the charge Q in between. Let the distance be small x, and this remaining distance is a minus x. So now suppose this charge is negative, so this 4e will try to pull this charge towards it. So let's consider this to be force A, because 4e is at point A. Similarly, this e will try to pull this q by force FB. So this FA and FB must be equal for the equilibrium. So FA and FB must be equilibrium, and if you put the values, you will get x to be 2a by 3. Now let us see what is the nature of this charge for stable equilibrium. So now suppose this charge is negative. So if q is negative, and suppose they are at equilibrium. Suppose if you move this charge a little bit this side, now you can see this distance has decreased and this distance has increased. So that means this force will increase and this force will decrease. Now this is the greater force, so this will easily pull the negative charge towards it. So equilibrium is not stable. If you move this charge by little bit, this equilibrium will be broken. So now let's see what happens if this is positive. Now at this point the forces are equal. So now if you displace this a little bit, this force will increase and this will decrease, but out here you can see they are both positive, so this will repel and it will go back to the same position. So at this position the forces are equal, so the equilibrium is not disturbed. So if the charge is positive, then the system will be in equilibrium. So this charge must be positive for the fixed charge. So for free charges it should be negative. So in previous question it was negative, but out here we are getting positive because these two charges are fixed. Now this is the same question as previous, but in this question they are asking the magnitude of q also. So to find the distance, we say these two forces are equal, so we'll get x to be 2a by 3. Now to find the magnitude of the charge, you must say the force of repulsion between 4e and e must be equal to force of attraction between 4e and q. If q is not there, then this 4e and e would repel each other. So in order to bring them together, we need a negative charge. So this 4e and e will repel and 4e and q will attract. If these two forces are equal, then only they will be at equilibrium. So if you use this and if you put x is equal to 2a by 3, then you will get q to be 4e by 9. So please don't skip the calculation, do all the calculation by yourself. Another question. So two charges plus q and small q are placed at a distance of x and x by 2 from this charge 4q, and these all forces are in equilibrium. So what should be the nature of this charge? So out here q and 4q, they should repel each other. So out here you can see this 4q will try to repel this. So in order to bring this at rest, you should place q out here, and this should be positive, so that it will push the charge q this side. So this q must be positive. So now to calculate the magnitude of this q, you can say this force Fa must be equal to Fb. Now using this you can easily find the magnitude, because distance is already given, so we can find the magnitude. So next question, 2 point charges plus 9e and plus e are kept 16 centimeter apart from each other. Where should the third charge small q be placed between them so that the system is in equilibrium? So you have to find the distance x, so you can do it in the same way we have done this question. So out here we don't need to find the magnitude. So next question, two point charges q and 2q are kept at a distance d apart from each other. A third charge q is kept along the same line in such a way the net force acting on q1 and q2 is 0. Calculate the position of charge q in terms of q and small q and d. So this is the similar question. Draw the diagram and write two forces to be equal, and if you solve that you will get this.